welcome to Saturday's edition of Cracking the Cryptic, where today we're going to be having a look at the puzzle on the screen, which is called Oscilloscope. Oh, nearly couldn't say that then. Oscilloscope, by Finnish Guy. And it's a very nice day for us to do this puzzle, because I believe Finnish Guy's son and daughter are matriculating from high school, or finishing their matriculation exams in high school today. So a big day for Finnish Guy's family. And hopefully this will be a little bit of icing on the cake if I can solve this puzzle. This oscilloscope has an interesting rule. It's a bit like German whispers, but not quite the same. And we'll have a go at this in a minute. I've got no clue, by the way. I've been given no hints as to how difficult to expect this to be. I'm starting this mid-afternoon UK time, having spent the morning being rained on the golf course. So, well, I can guarantee one thing: it will improve my mood, even if I can't do it. Now, what do I need to tell you about today? A couple of things. Firstly, on Patreon, well done to all those of you who have, well, we've had over 1,000 correct entries to the standard pack of Japanese sum Sudokus created for us by Panthera, the Asylum, and Grockles. Absolutely stellar solving from so many of you. We are still getting, well, not still, we are starting to get more entries as well. For the doctoral pack, which is this enormous pack. It's about 35 or so puzzles, and well done to Awesome Source 21, to John Gemmell, and to Kapateki. I hope I'm saying all those names correctly, because you've all finished the doctoral pack correctly in the last 24 hours. I hope I'm not missing out any names. If I am, drop me another email and remind me, because it'll mean that I've failed to pick up your emails in my searches that I've just done to get those names out of the system. Then what else do I need to tell you? By the way, if you want to know what we're talking about in terms of these packs of Sudokus, just get over to Patreon. It's a couple of bucks a month, and honestly, I promise you, it is absolutely worthwhile. It is. There is some amazing extra Sudoku content over there, produced by some of the great and the good of the Sudoku world. So it really is worthwhile. Now, I want to give a shout out to my mate Dave. Now, this is a funny one to me. Dave is a sort of wizard of Excel. He's the Gandalf of Excel, and for some reason, Alexa thinks I said her name. I didn't. I said Excel. That's not the same. Anyway, Dave is he's the goat. You can see. I'm not going to say the name again because I don't want to wake up the lady beginning with A. But Dave has created a YouTube channel. You can see it's got 12 subscribers at the moment, so it's only of modest size. I remember those days well. They don't seem that far away. But Dave's approach to creating a YouTube channel has been to basically make absolutely amazing content, and all up front. So it's weird to Mark and me as a strategy, because what we did was we sort of bumbled along for ages trying to work out how on earth to make good videos. But Dave has mastered that no end. I think he just needs a bit of help from the algorithm. So if you have any interest in getting good at the word beginning with X here, you could do a lot worse than go to Dave's channel, ExcelGoat. I'll risk it. She didn't wake up, and have a look, because the videos there are very good. Now, what else do I have to tell you? Nothing. Let's have a look at Oscilloscope. I'll read you the rules. There are quite a lot of rules today, but I read through them just now, and they all seem to be very standard apart from the red line. So here we go. We've got normal Sudoku rules apply. The red line is an oscillator line, along which digits alternate being high, more than 5, and low, less than 5. So this is almost like a German whisper. When I first read the rules, I thought it was a German whisper, but then I realized no, it's not saying quite the same thing as a German whisper. In a German whisper, if this was a 6, because on a German whisper line digits have to be 5 apart, this would have to be a 1. Here, if this is a 6, this doesn't have to be a 1. It could be a 2, a 1, a 3, or a 4. It just has to be lower than 5. So there's no stipulation as to how far apart the adjacent digits are. We simply have to, as the word says, oscillate. Now, clues outside the grid give the sum of the digits along the indicated diagonal and may include repeated digits if permitted by other rules. So that means that these cells here sum to 25, and we could absolutely do something like that. Except for, of course, that's going to break this arrow. But these 9s don't see each other, so there's no reason apart from this arrow line to say that this arrangement would be impossible. Now, what else? Digits may not repeat along the main diagonal marked in blue. So that's this diagonal can't have repeated digits on it. Grey lines are palindromes, which read the same forwards and backwards. So that's telling us that if this digit's a 1 and this digit's a 2, then we'd have to complete the line like this. So if we read it from the top, it reads 1, 2, 2, 1. And if we read it from the bottom, it still reads 1, 2, 2, 1. So that is palindromic, and that would be a legitimate way of filling this grey line. Digits along an arrow sum to the digit in that arrow circle. So these 3 digits here, let's make those 1, 2 and 3, sum up to 6. Whoops, mistyped, lost my army. So this would be a legitimate way of filling the arrow. And is there any more? Yes, there's a bit more. The cell with an opaque grey square contains an even digit. So this cell here is even. And that is all of the rules. Do have a go. The way to play is to click the link under the video as usual. But now I get to play. Let's get cracking and see how we go. And we'll start off where? We'll start off, shall we, by labelling this cell. Because the minimum we could have along this arrow would be a 1, 2, 3 triple. We know that the circle must be at least a 6. So this is at least a 6. 25 on this diagonal is... I was about to say that feels high, but actually it's not very high, is it? 4 digits there. So it's averaging only very slightly higher than 6, which is, you know, given that the average Sudoku digit is a 5, is not perhaps as interesting as we would hope it, or we would like it to be. It's a slightly dull person to get introduced to at a dinner party, this 25 clue. The 9 clue is... don't know. 9 has 3 ways of being made up in 3 cells if the digits have to be different. It can be 2, 3, 4, 1, 3, 5 or 1, 2, 6. Don't know how to do that. 15 is... So again, this is averaging very slightly on the low side, isn't it? Just under 4, but that's not helpful. 8... okay, so 8 must have a 1 on it in 3 cells. So this is either going to be 1, 3, 4 or 1, 2, 5. So this cell has got to be a 2 or a 4 because we know that this one is even. Yes, okay, and now we can use the oscillator line because those 4 cells there are alternating on the oscillator. So although we don't know the order of how this works, we know that if this was low, for example, then we go high, then we go low. So these 2 are the opposite sort of polarity, if you want, to those 2. Now, if therefore the 8 diagonal contained 3 low digits, if it was 1, 3, 4, then we couldn't have 2 low digits on the oscillator in box 9, and we know we need to. So that breaks the box basically, and we mustn't break the box. So what we need this to be is 1, 2, 5, and that means we get a digit. So we're off to the races. We've got a digit there. We've got a 1, 5 pair here. And what's that doing then? That doesn't seem to be doing very much at all. Oh, how strange. I don't think the palindromes are useful. No, I don't like the look of the palindromes at all. So it must be something to do with the oscillator line, I presume. So if we've gone, so this just continues, doesn't it? I see. So we get, oh, I see. So we sort of get that pattern going on for the blue digits, which means we're going to get this pattern going on for the orange digits. That does make me think about set, I have to say. And I've done a puzzle by Finish Guy before where I distinctly remember it was about set. It was a checkerboarding, I want to say, of the whole puzzle. So I know Finish Guy does like set. But what is the set that we draw? We've presumably got to... I want to keep the digits of opposite parity in different sets, don't I? So let's try and just do the most obvious thing we can do there. Let's have a look at that configuration. How am I going to do this? Or should I use a new grid? I don't know. I'll go along with this, and then we'll change it in a minute if it looks like it's not the right set. So we'll go like this, and well, I suppose I should explain what I'm doing. If you're new to the channel, you will not know what on earth I'm doing here. What I'm doing is, well, in fact, a few days ago I did a puzzle called the Scrabble Bag Equilibrium, and that is what I'm doing. I'm trying to equalize my Scrabble bags. What on earth am I talking about? Well, let's look at row 2 and ask ourselves the very simple question: what digits are in row 2 of this puzzle? Now, row 2 will contain a set of the digits 1 to 9 in some order. So that row is one set of the digits 1 to 9. This row is another set, this row is another set, and this row is another set. So the orange digits altogether are 4 complete sets of the digits 1 to 9. Now, the best way to understand what I'm doing here is to imagine that I got 36 Scrabble tiles, and onto each of them I wrote these digits down. So although I don't know the order, I don't know if this is a 3 or this is a 3, I don't know where the 3 goes in row 2. It doesn't matter. I know there's 1 3 in row 2, so for row 2, from row 2's perspective, I'm going to write 1 3 on a tile. From row 4's perspective, I'm going to write 1 3 on a tile, etc. So in my bag of orange Scrabble tiles, I'm going to have 36 tiles. I'm going to have 4 of those tiles with a digit 1 on, 4 with a digit 2, 4 with a digit 3, and then 4 all the way through to 4 with a digit 9. Now, what have I got in my blue bag then? So in my blue bag, I've got the whole contents of column 2. Well, that's a set of the digits 1 to 9. This is another set, this is another set, and this is another set. So in my blue bag of tiles, I've got 36 blue tiles, and I've got 4 digit 1s, 4 digit 2s, etc. So I've got exactly the same thing in my orange bag of tiles and my blue bag of tiles. Why does this matter? Well, I don't know yet, but I'm hoping it might matter, because what I then want to do is go and find this digit in my orange bag and my blue bag. And you may say, well, you don't know what that digit is. You're quite right, I don't. But I don't need to, because this is what we're doing here is finding an equivalence between the geometry of the puzzle. So whatever this digit is in the finished solution, let's say I knew what it was, I'm going to go and fish it out of my blue bag, and I'm going to fish it out of my orange bag, and I'm going to throw it out of both bags. You don't have to throw it, you can just put it aside, but I'm going to throw it away. So what then can we say about the contents of the orange and the blue bag? Well, we can no longer say we know exactly what's in the bags, because we don't know at this point what this digit was that we've thrown out. But we do know that we're left with 35 tiles in the orange bag and 35 tiles in the blue bag. And because we know this digit is the same, it's in orange and it's in blue, we know the contents of the bags is still the same. And I can do that for every digit that's got a blue and an orange flash. Look, I can throw all of these digits out of both bags, including that one, and I'm left with this pattern. So now I've got, I don't know how many I've got left now. I've got 20. It looks like I've got 20 in each bag left. And I know that I don't know what these digits are, but I know that the 20 tiles left in my orange bag are identical to the 20 tiles left in the blue bag. Now, okay, so now I can throw, if I throw that digit out of the blue bag, I know I can find that digit in the orange bag here because this is a palindrome. So I can throw those two away. I can throw these two away. They're on the palindrome, therefore they're the same. I can throw these two away. I can throw these two away. One. Okay, and how many digits have I got left now? Right. Is this right? Right. I think I understand this. I think I do. Yes, I do. It's finally clicked. Right. This is very, very beautiful. This is exactly, I think, what we're meant to be looking at, because now, at this point in our solve, we know that the orange digits and the blue digits are the same. So let's just imagine for a moment that the orange digits are low on the oscillator. Then we would know that these digits here, these Scrabble tiles, contain low digits. But we know that the blue bag must have the same contents as the orange bag, but in the blue bag we know that because of the oscillator line, these digits cannot be 1s, 2s, 3s and 4s because they're on the oscillator line. They have to be the opposite. So that means in the blue bag, the digits that need to be the 1s, 2s, 3s and 4s are the digits that are off the oscillator bag. And there are, I think, exactly 8 of them. And that is rather beautiful, isn't it? Because that means if we count 1, 2, 3, 4, 5, 6, 7, 8, we know there are 8 low digits in orange, so there must be 8 low digits in blue, and because they can't go on the line, they have to be in these positions. So, and obviously this works vice versa. There's going to be, now the only issue here, how am I going to do this then? So now, I mean, I can see one thing it's going to mean straight away, and that is that the blue digits have to be low. I've done this the wrong way round, haven't I? Oh, have I? Hang on. Oh no, this is right. Okay, we're going to have to recolor the grid, because it is, everything I've told you is true, except perhaps what I was about to tell you. That might not have been true. Because if we focus on the oscillator line, there are 16 digits on the oscillator line. And we know that the orange digits on the oscillator line have to appear in the blue digits that are not on the oscillator line. So these blue digits here have to be the digits 1, 2, 3 and 4. And therefore I want to make them orange, but I'm conscious if I make them orange, I'm going to have too many oranges. So hang on, we're going to have a placeholder here. I'm going to make those purple. These purple digits are the same, they are the blue bag's equivalent of these orange cells. Now, we know that these blue digits have to appear in the orange bag, and because they can't be the same as the digits on the oscillator line, they have to be these digits, therefore. So these orange digits are the same as blue. And now I can turn purple back into orange and without polluting the world. So now, right, now we need to, well, actually I've been lucky here. I've got my pencil marking correct. Of course, at this point, before we do anything else, we don't know whether orange is high or low, except we now do. Because we know there are 2 orange digits on this arrow. So if these were 2 high digits, this arrow would be a double-digit number, and that doesn't work. So orange is low, and that means these cells are all 1, 2, 3 and 4. And they can't be 2, or actually all 1, because they see the 1, 5 on the 8 diagonal. These can't be 2. And all of the blue digits now have to be 6, 7, 8, 9. I'm not sure actually. It might be more sensible if I don't label these up, just because it looks a lot more cluttered when I do. I'm not sure about that. Let me think about this for a second or two. Yes, okay. So looking at box 9, I've got a 1, 2, 3, 4, 5 quintuple there. So these two are blue digits, but I need 2 more blue digits. They've got to be in those cells, which I suppose I'll label up 6, 7, 8, 9. I've now got lots and lots of 6, 7, 8, 9s in column 9. So everything else in this column has to be from, well, the problem is it could be a 5. So I can't orangify these legitimately unless I know that's a 5 for some reason. Oh no. No, I'm not sure. Right. No, I can do something here. I can do something here. That was a bit of a pregnant pause, wasn't it? Look at the 9 diagonal. So this 9 diagonal, if that was how do I do this? If this was 2, 3, 4, like this is one of the options for 9. Those two squares would both have to be 1, and that won't work. So this is not 2, 3, 4. And therefore what is it? And the answer is I don't know. But it's either 1, 3, 5 or 1, 2, 6. And that's beautiful. In fact, I do now know what it is, because it must have a 1 on it. And if it's got a 1 on it, these two squares can't be 1, and they are a 3, 4 pair, and now this can't be 1, 3, 5 anymore. So this is 1, 2, 6 on this diagonal. And now that cell must, I think, be 5. I've used up 1, 2, 3 and 4 in the box. That is a 5 in the corner, and therefore we can get rid of some 5. Look, now we get 5 down here, we get 1 here, we get all sorts of stuff going on. There's got to be a 5 in one of those cells. We've got 1, 2, 6 on this diagonal, so these two cells can't be 6 anymore, and we need another high digit, so that is a high digit. That is a 7, 8 or a 9, and it can be bluified. And I have to say, this is a very, very cool idea. I think Finnish Guy has almost got the monopoly on these set break-ins, where it's sort of the whole, you have to do the whole grid almost. And there's this, you know, these beautiful ideas around sort of either parities or different sized digits. It's very cool indeed. So, actually, can that be a 6 now? Oh, maybe it could. No, it can't. Right, if this is a 6, because that's at least a 3, and this is at least a 1, this would be a double-digit number. So that is only 1 or 2. And that looks like it's given. Look at that. I've got a 1, 2, 3, 4 quadruple in the top row. So this cell, obviously that can be blue because it's 6, 7, 8 or 9, and both of those have to be blue. So now, to complete row 1, I've got to put 5 in one of those. So these get properly Goodliffe, but they don't get orangified. Do we know what this 25 diagonal is? Oh, you can't put 1 on it. You can't put 1 on it, even if that's double 9. Even if we make these as big as we can, they only would add up to 22. So we need this to be at least a 3. So is it the same? If we double 4 that, we still need at least 17. Yes. Okay, so these can't be 7 or 6 because well, even if I make these double 4, that's 8. That means these two have to be at least 17. So the minimum value of this is an 8, 9 pair. But they could they could be double 9 if these are different. Oh, that's rather pretty. Right, I can tell you these are not different, because if these were different, how would you fill this square? If this was a 3 and this was a 4, this cell would have no possible value. So these must be the same, and they can't be double 3 because these can't be a 9 and a 10. So these have to be double 4. That has to be 3. This is no longer a 3 or a 4. These are, oh, this is so gorgeous, right? And now I can play that trick again, because now I've got 8 here, so these are adding up to 17, which means this 8-9 pair are different, and therefore that can't be 8 or 9 and has to be 7. That's lovely. So this is an 8-9 pair. 7 can come out of some cells down at the bottom, look. Can we keep that going? The answer is I don't know. Oh bother! Oh, those two have got to be orange. That's shouting at me now. So that's got to be orange. This one we don't know because it might be a 6. And are we going to be surprised if this disambiguates from here? Maybe not massively. Right. Okay, so now we've got 7 on this arrow, and we're adding 1 or 2 to that. So this is 8 or 9, which means in this box, well, in row 1, we must have a 6 or a 7 in these cells. So this can't be 6 or 7. In fact, these 2 cells you can see are the same. So those 3 cells are the same. I've got an 8-9 pair in row 3, so this square is no longer 8 or 9. This is 6 or 7. One of these 2 squares is 6 or 7. And 2 is looking at that cell. So this is, we still can't get this 9 diagonal sorted out. It's close to cracking though. Okay, I can't see anything there. So we haven't looked at the 15 diagonal yet. Which needs to be low. It's got 2 high digits on it. So yes, you definitely can't put 8 or 9 in either of these cells. If this is an 8 and this is a 6, these would both have to, together these would have to add up to 1, and that doesn't work. So this is low stuff here. So this, oh, okay, but this could be double 1. That's annoying. Right, so if this was a 6 and a 7, that would be 13. We'd need a 1 in both of those. Oh, no, that can't work. This one can't be a 1, actually. So this one is at least 2. Oh, okay. If this is 2, how on earth do we make this work now? These must be the same, and they must be 6, because we're already, if this is double 6 plus 2, we're already at 14. So this is a 1, this is a 6, this is a 6. That should be helpful. Maybe. 1's come out of this. Oh, look. That's become a 2 at the top. That's gorgeous, because that gives me a 1, a 6, and a 2 on the 9 diagonal. 6 can be coloured in blue. 1 and 2 can be coloured in orange. This is no longer a 1. This is no longer a 2. This is no longer a 4. And come on, this must do something else. This tells me that 4 plus 1 plus 3 is 8, so that's become an 8. Didn't we work out that this was the same as something? Yes, this is the same as that by Sudoku, so that's an 8, which means this is an 8, this is a 9. This is just lovely, isn't it? So now we've got a 6, 7, 9 triple in box 1, of which that can't be 6, that can't be 6, so that's a 6. I keep wanting to use German whispers logic, but I've managed to resist it so far. Those 2 cells can't be 6 by the power of 6ness. And, oh, that can't be a 6. So where does 6 go in column 9? It has to go in the corner, which doesn't get a song, but it does get a 7 done. So now I've got an 8-9 pair here. 6 has to be in one of these 3 cells. 7. Okay. So in this column we've got to put a 6, and it has to be in one of those 2 positions. Oh, that's annoying. I wondered whether the palindrome would rule it out of being here, but it doesn't, I don't think. In fact, the palindromes are proving remarkably unhelpful so far. Let's see though, we've got 2, 4 here, so we can get rid of some 2s and 4s in box 1. And a 2 here, no, that can't be 2. So that can't be 2. 2 in this box is in one of 2 places. Hang on, so what exactly have I not done now? Oh, look, I've not done the 25 diagonal. I was just thinking, how is this going to disambiguate? But I've got 16 there. I need another 9. So that's a 9. That's an 8. Even that doesn't feel like it's going to be enough, though. Maybe it will be. This is 7 or 8. Oh, so I've got a 7, 8, 9 triple in this column. So these squares have got to be on the low side. This cannot be 1 or 2. That cannot be 1 or 2. Oh, lovely. Okay, there's a 3, 4, 5 triple in box 7, and the 5 in that triple has to be in column 1, so that gets rid of a few more cells. Has that broken the back of it? The answer is, don't know, but I can put 1 into box 7, so this is not a 1 anymore. 1 is of course an orange digit. And that means I've done, okay, so I've done all my low digits in row 8. These have to be either 5, unfortunately, or 7, 8, 9. That can't be 8. That's on the palindrome. That's the first thing we've managed to label on the palindrome, so perhaps we should explore this. This is 5, 7, or 9, and that's really annoying. All of those seem to be okay. Okay, that's not what I was anticipating. No, I was about to exclaim there's a 2, 4 pair in this box. That's not true because I don't know what this digit is yet. Okay, let's have a look at column 8 because I can see we actually know the contents of these cells in theory. These are 1, 5 and 7. And this one can't be 7 because its reflection goes there where it sees a 7. So this is 1 or 5. And that is very... Oh, is that doing something? I don't know, actually. It might not be. What about this column then? We need 2, 3, 4 and 6 into these squares. So perhaps this cell is restricted. Yeah, that is more restricted because that goes here where it cannot be 2 or 4. So this one seems to have to be just 3 or 6. And that just, has that done something good? I don't think it has actually. It seems to be close to doing something, but not quite. Oh, you know what I haven't thought about? Because I couldn't really see it until I suddenly thought, how am I ever going to do this puzzle? I haven't thought about this diagonal at all. Is that... Well, okay, yeah, that 5 in the top is ruling a 5 out of here. That is good. That seems to say this has to be a 5. So that's... Now I've got a 3, 4 pair. Good grief. Okay, so now... Right, so now we've got to be on alert for the positive diagonal. Now, is this 5 doing more than that? It is. Not sure, but this 3, 4 pair is... That's looking at that cell, making it a 2. So we'll definitely put that in. Although that's rather underwhelming as well. It doesn't seem to have done very much. But we have now got lots of digits in row 9. So these have to be 7s, 8s and 9s to complete the row. They get bluified, and we can see from that this can't be 8. And I want to say, if we look carefully at box 8 now, we've got these cells that have to be from 5, 7, 8, 9. Once we add this cell in, that's a quadruple on 5, 7, 8 and 9. So this cell has to be a 6. And also these two squares have to be a 3, 4 pair. And one of those is on the palindrome. Let's just see if we can use this 6 before I move swiftly on. This can't be 6 anymore. Look, yeah, that's got that one. So that's a 3, that's a 3. Oh, happy days. That's done so much damage. Good grief. Look at what this has done. So not only does this 3 see this cell and make this cell a 1, I've got to actually be careful here because I think this is doing so much work. This become a 5. So these cells have become a 2, 3, 4 triple. 5 is in one of these cells as a result of that. 1 is in one of those 3 cells. Can't be on the palindrome. But this 3 has bounced back over here, and that's making this cell a 4, this a 3, this a 4. We can get rid of some 4s over here, so this has become 2 or 3. This has become, a 6 in this box has got to be placed now. That's become a 2. 3 can be knocked out of various cells. 2 could be knocked out of various cells. And, so these are 1, 5 and 9 at the top as well. We know what these are in row 2, sorry. 1, 5 and 9. So this is a 6, 7 pair. We can colour those in. But also, what else did I see? I saw something else. Was it this 3, 4 on the palindrome? Yeah, this cell's got to bounce back over here on the palindrome. And that means what? Has that done something good? I don't know, maybe. That's got to be blue, that's orange, that's orange. So 6 can be placed, look, in box 5. It can be placed here exactly. Let's take 6 out of that cell. How many? Oh, that 6 does the top, 6 and 7. This is not 7 anymore, this is not 7. How many 6s have we got? All of them. How many 7s have we got? Not very many. Really not very many. Oh no, actually that's, yeah, okay. I was about to claim there was a 7 in one of those. There isn't at all. There is an 8 in one of these cells, so that cannot be an 8. So, so where does 8 go in this column? It seems to have to go here. Which does absolutely nothing. That's unbelievable. Oh, you rotten puzzle. Okay. So we're sort of scraping our way to extra digits. Okay, we've got a 3, 4 pair here. So this cell has to be an 8 or a 9, and that is giving me something I can see. It's giving me a blue digit and a 7, 8, 9 triple in this column. So everything else, because 5's gone, needs to be low digits. So both of these are low, including this one, which cannot be a 4. So this is 1, 2 or 3. Now I've got a 1, 2, 3, 4 quadruple in box 4. And that can't be 4. So this string of digits contains 1 and 4, which means that can't be a 4. Still not, I don't think that's quite doing enough. These have got to be 5, 7 and 9 to complete box 4. That can't be 9. And oh no, come on, give up now. You've almost been defeated, but you're still being recalcitrant, and that's very frustrating. Okay, Oh no, that's not true. I was about to say this is a 1, 3, 4 triple. It's certainly not. That can still be a 2, so that breaks that idea. Right, so what are we, oh, maybe it's this diagonal again? I keep forgetting this diagonal, don't I? Oh gosh, it is. Look, that's a 9, so that's an 8. Good grief. Ah, so that gets me the 9 over here and the 8 over here, which actually doesn't do very much. So, but I think this is where we have to focus. So we've got 2, 3, 4 and 7 to place into these cells. 2, 3, 4 and 7. That can't be a 2. That can't be a 2. So where does 2 go on this positive diagonal? It goes in the middle. And that gets rid of 2 from here. Oh, all that's doing is giving me my my 1, 3, 4 triple. 1 has to be on one of... that's good though. I've got a 1, 3, 4 triple, so that becomes a 5. That's on the palindrome, so that becomes a 5. This is no longer a 5 over on this side of the grid. This 2 is seeing that cell, so that's got to be a 3. 3 and 4 go in. 2 up here. 3 and 4 go in here. Let's make that 4 orange for the sake of sanity. This 3 is giving me a 4 here. So these become a 1, 2 pair, and the 2 does the work. So 2 and 1 go into the grid. Make the 2 in the middle orange as a reward. And now we will do something else, which is we will use 4 here to get rid of that option. 4 comes out of here. Okay, good. But this, oh, I see this 4 here is ruling 4 out of there. Yeah, so it's the positive diagonal. I've really neglected it. There's a 3, 7 pair now, so that's got to be 1, that's got to be 4, that's 3, that's 4. That 1 is doing the 1s and the 7s over on the other side of the grid. We can orangify all the 1s. We've got a 7 here, which is doing the 7, the 3, the 5 up here now. This has got to be 9, that's got to be 7, that's on the palindrome, bounces back down here, gives me a few more digits. We just need 5s and 8s into those cells, I think. Is that resolved? Probably. I've now got an 8, 9 pair in this box, so this cell's a 5. That's not a 5. That's a 9. That's a 1. That's a 9. That's an 8. That's an 8. That's a 5. That's a 7, that's a 9, and yes, I am aware I have not coloured in everything, so let me try and fix that. 7s are high digits, 8s are high digits, 3s are low digits, and I've probably still missed, oh, that 8 is now, why has this got 2 colours? I do not know. I don't know why 8s and 7s have got, and suddenly my 8s and my 7s seem to have been multicoloured. That's probably, I've just misclicked on something a moment ago. I did not mean to do that. They should all be blue. That one's still trying to be difficult. That one's still trying to be difficult. That one's still trying to be difficult. That one is still trying to be difficult. Right, have we actually finished the puzzle now? Perhaps. Oh, no, no, no. I've got a 7 and an 8 here that are not blue. Oh, goodness me. I've made an absolute horlicks of my colouring here. Oh, people are going to get so upset. I'm sorry about this. And I'm going to try and fix it before I click tick to see whether I've got the puzzle right. And I'll have missed a digit, and then that's all anyone will comment on. Okay, have we done it now? It does look like it is sort of coloured in a binary way, apart from if we ignore the white 5s. Let's see. Yay, we did it. Oscilloscope completed. And that was very, very clever, Finnish guy, again. And I think, to be honest, I think I was helped in solving that by the fact I've solved Finnish guy's puzzles before, and I could remember that set was relevant last time. Well, I didn't remember it at the start, but I remembered it once I started to think about the fact that the way that this oscillator line was working was that you kept getting the same polarity of digits in a very regular pattern up the oscillator, and that allowed a way in. So I hope you had a go at the puzzle. I hope you got through it. Let me know in the comments. I do enjoy the comments, especially when they're kind, and we'll be back later with another edition of Cracking the Cryptic.